All right, let's take a look at the show and share portion at the top of page 665. And we'll see what we can do with that. Use the table for 1 and 2. Many pools come in rectangular shapes. How do the pools of the swimming pool change when the widths change? First, we need to complete the table by finding the area of each pool. Then, see if we can't find a pattern. So, let's see what we got here. I think that we can say with some degree of certainty, length times width, so the area of this pool, if we think of that as 8 times, whoops, wrong key there. 8 times, I can't get my key there to work. 0, 2, 1. There we go. Oh, almost. There. So 8 times 2 is going to give us 16. So if we add a 0 here, that means that we are going to add a 0 right there. Okay, so the area right here becomes 160. All right, let's do just a little bit of property stuff here. There we go. So we'll kind of put this up out of the way right here so you can see how we're going to do this. If we go 8 times 3, that's 24. 8 times 30 is going to be 240. All right, 8 times 4 is 32. 8 times 40 is 32 with a 0 at the end. Okay, so we've completed the chart. Let's see if we can't find a pattern. Find the pattern of how the lengths change and how the widths change. So this right here, this portion, this changes. All right, and we want to know how does that impact? How does that impact the change that we see right here? All right. Well, at first glance, what I am seeing is that we can go from 160 and 160 right here. So when we add this up, right, we get this number right here. So when we doubled, when we doubled from right here to right here, from 20 to 40. We also doubled the area. All right. So let's see if we can't figure out some things down here. Find the pattern of how the length stays the same. All right. And the width, and I guess we're just looking at it right here. Find the pattern of how the lengths change and how the widths change. So we weren't really looking at the area yet. The length stays the same, and the width increases by 10 feet. All right. What if the length of each pool, or what if the length of each pool was 16 feet? Explain how the areas would change. So what we're going to do now, all right, is mark this out and make it 16 and make this 16 and make this one 16. If we doubled the length, what do you think is going to happen to the area? All right, and we've discussed this in a previous video. Okay. Double the length will result in double the area. And you know what? We're going to add add something, or double the length and keeping the width the same will result in double the area. All right. So, as we continue along here, I want to make sure I'm not missing anything because there's an open area right here. What do you think would be D if we made that the original 8 and then we increased it to 50? All right, so we keep looking at this pattern increasing by 10. Well, 8 times 5 is 40, and then add another 0. So what is the pattern? I got to tell you, this is kind of driving me a little bit crazy here. Let's see if we can't find a calculator here. An interactive calculator would be even better. But I don't think I'm going to be able to find it. So I'm going to have to do this the old-fashioned way. Got 400 minus 320. And that is going to give me 80. Well, what is 320 minus 240? I see something here. That's also 80. So this pattern from here to here is always going to be 80. All right. So a lot to look at, a lot to think about there. I guess the bigger question would be, why 80? And your hint would be right here, when we double 20 to 40, then we double the area 160 to 320. But if we don't double it, if we just increase it by 50%, we're not increasing by the full 160, we are increasing by half of it. And what is half of 160? You guessed it, 80. All right, like I said, there's a lot of fun stuff with this, and I've always enjoyed it. And I hope you enjoyed as much as I do.